Hey guys, this is Corey from 1301, and in this video we're going to be talking about selection sort. This is one of the few sorts that you guys are going to need to know how to actually trace through each iteration and kind of figure out or kind of make sure that you know how this algorithm works. The first thing you should know about selection sort is that it has a runtime of O of n squared. So this is one of the slower ones that you're going to learn, but let's just go ahead and get started with how the algorithm works. So when we're looking at selection sort, kind of like how the name implies, all you have to do at each iteration is basically look through all of the numbers for the smallest element, and once you find that element, basically put it in the position where it needs to be, and then look for the second smallest and put it in the second position, look for the third smallest, put it in the third position, so on and so forth. So there are a couple ways you can do selection sort. You can sort them from least to greatest or from greatest to least, but I normally just do least to greatest, so we'll do that for the sake of this video. That's pretty much like what we normally do in class as well, so we'll be sure to make sure that that's clear on the exam. So let's just go ahead and get started. So if we look at this original list here, so this is after 0 iterations, we can just see that it's obviously out of order. So basically what we would do on our first iteration is we would just go through this list and look for the smallest element. So here we can see that the smallest element would be 1. So all we need to do is basically, we know that 1 was the smallest one we found, and because this is our first iteration, we know that 1 belongs at this first position here. Just because like in the sorted list, 1 would be in that first position. So how selection sort works is once you find an element that you want to like put in its right place, basically all you have to do is swap it with whatever was there, just so we have a place to put 7. So all of the other elements will still stay in the same order. So like one way to recognize selection sort is that after each iteration, like comparing one iteration to the one that came before it, only 2 numbers should be in a different location. So like when you have bubble sort, things will all kind of elements, like all of your elements can be moving around as you're bubbling larger elements up. But in selection sort, you're only going to have 2 elements changing positions at each time. So after we make this swap here and we put 1 in the smallest position here, or in the first position here because it was the smallest, we basically know that now 1 is guaranteed to be in the right place because obviously the smallest element is going to be in the beginning area. So another thing to know about selection sort is that however many iterations you have, that's how many guaranteed spots you have. So number of correctly positioned elements is equal to number of iterations. Sorry, my handwriting's really bad. So basically, at this point, all we have to do is keep doing the exact same process. So now, if we want to find out what it looks like after our second iteration, we know now that because 1 is already in the guaranteed spot, and this red underline can basically correspond with it's guaranteed to be in the correct spot, we no longer have to look at 1. So now we're wondering what is the second smallest element. So basically, we can kind of just like disregard everything that's in the red region and just look for what is the smallest element from the remaining section. So looking through each of these one at a time, we can find out that 2 is the smallest one. So now we know that 2 belongs in this position. So we can just go ahead and swap 2 and 4. And like we mentioned before, all other elements stay in the same position. And since we've made this swap, we know that these 2 are guaranteed to be in the correct order. So we can just go ahead and keep working through this example. So of course we have 1 and 2. We don't need to look at them anymore because they're guaranteed. Looking through the remaining ones, we have 3. So 3 just needs to swap with 5. So this list as our result of after 3 iterations. And of course, these 3 are guaranteed. So it's a pretty straightforward algorithm. If you're wondering like maybe like a good method of remembering which of the algorithms are doing what, if you kind of just pay attention to what the names are, that's pretty much like they're kind of giving a hint for how the actual algorithm works. So at each iteration, you're really just selecting what goes in the next spot. and swapping it with whatever was there. So just try to remember that the names are probably the biggest hints that you guys will have. So we're going to do another example after this one to kind of show you guys some tricks that normally, or like one trick that normally kind of messes up some students. So of course here, 5 is our smallest element. We'll swap that with 6. And then this is our guaranteed area. And then you can see here that the list already happens to be in order, but regardless of that, that's kind of just like a coincidence. So even if the list kind of already sorts itself out, you still have to complete the iterations until you have one element left. So here we know that 6 is the smallest one, so we can go ahead and redraw our guaranteed area. Oops. And then 6 kind of like swaps with itself here. 7 remains in the same place. And now this is our guaranteed area. So the thing about selection sort is that once you perform n-1 iterations, you're basically guaranteed that all n elements are going to be sorted in the correct order. So as you can see, there are 7 elements in this list, but we only needed to perform 6 iterations. And that's basically because once you perform n-1 iterations, that last element is already guaranteed to be in the last spot. So basically what this is saying is that because 7 is the last one, 7 is the 7th smallest element in this list. So that's pretty much, you can stop after n-1 iteration. So we'll go ahead and write that. Can stop after n-1 iterations. So with that in mind, you can kind of also just extend this red underline region to here. So you can see here, this was only n-2, but once we made sure that 6 was actually in the right spot, then we were guaranteed that you can just kind of underline those last two at the same time. So let's just scroll down and start another example. Okay, so here, this one's going to be our second example, and this is kind of just to show you guys that even though sometimes certain elements don't swap, we still need to just be sure to continue throughout all iterations necessary to make sure that the list is actually in sorted order. So for example, here on this first iteration, 8 is actually going to be our lowest one, and it's already in the right place. So when you write out this list after the first iteration, coincidentally, it happens to be identical to the first one, but you still have to write that out and count it as an iteration on its own. So and we'll see right now the same thing is going to happen again with 9. So if we just go ahead and write these two iterations out, this is what the list looks like after 2 iterations, and it happens to be the exact same thing as our original list. But now we know for sure that that the first 2 are for sure in the right order. So basically, what this is just this is basically just to exemplify that even though sometimes in iterations the elements don't move positions, it still counts as an iteration, and you still have to write them out individually. So of course, we'll go ahead and move on to the next one. The next smallest one is 10. So we're going to swap that with 15. And then basically just fill in all of the other ones because they're not going to change. And of course, we have this sorted region here. So just one thing is just to not get tripped up on when things are switching or when things are not switching. Kind of like what we mentioned before, you have to always do n-1 iterations. So here, of course, 11 and 14 are going to switch places. And your guaranteed region grows by 1 each iteration. So I know this is kind of repetitive at this point, but we'll just go ahead and finish it. So of course, 12 is the last spot, or the lowest value. Oops, my bad. So yeah, I meant to switch 15 with 12, and then the remaining elements stay the same. steps here, 13 and 14 to switch places. And then this is just like we saw before. So even though coincidentally now the list happens to be in sorted order, we have to go ahead and actually do that last iteration to make sure. Because at this chance, like at this level, there's still a chance that maybe 14 and 15 would be in the wrong order. So you just need to basically do it one more time just to guarantee that those last two elements are properly arranged. So 14 is the lowest of the two, so it kind of swaps with itself. 15 stays in the same place. And then just like we did before, you can throw both of these last two elements in at the same time. So of course here this list contains 8 elements. So in this example, n was equal to 8, but the number of iterations we needed was only 7. So this is with that same like n minus 1 number of iterations to find out that, to be sure that the entire list is complete. So hopefully this video cleared up some of your questions on selection sort. Yep, so thank you.